Okay, you guys, we are starting a new section of solving quadratic equations. We're going to be solving them by the quadratic formula, which is super duper duper important. You need to know this. You need to understand this. Moving on in math, you're going to use this a lot. This is super important. You know how some of the stuff is important, some of the stuff is okay, some of the stuff is fluff. This is not fluff. This is not okay. This is good, important stuff that you need to know. So you need to know it. You need to memorize it correctly. I'm going to show you the quadratic formula up there right now. There it is. If ax squared plus bx plus c equals 0, that's the form you need to have your equation in, then x equals the opposite of b plus or minus square root of the quantity b squared minus 4ac, the whole thing divided by 2a. That is super duper important, okay? You need to memorize it. It's not like, oh, you can memorize it if you want to. It's like you need to memorize that formula. You need to have it down. And not only that, even more important than memorizing the formula is you need to memorize the formula correctly, right? Because I cannot tell you how many times, well, not that many people, but sometimes people memorize the formula incorrectly. Then they get every single problem wrong because they memorize the formula incorrectly. So you need to take the time and the effort to memorize this formula and memorize it correctly. X equals negative b plus or minus square root of b squared minus 4ac, the whole thing over 2a. Very, very important. Okay, so that's what we're going to learn today. Super important, okay? But before we do that, I want to show you the type of answers we get using the quadratic formula, the sort of answers you end up with. And the reason I'm doing this, I didn't used to teach it this way, but I've learned that one of the main things people have trouble with is sometimes they'll put everything into the quadratic formula right and get it down to a certain point, and I'll show you what point they usually get it to. But then after that, they don't know how to simplify it from that point on. And that happens a lot. I even see it in Algebra 2. It shouldn't be that way because you guys should already know how to simplify stuff like this, but I see over and over people not being able to simplify from this point on. So what I've decided to do is to show you guys how to simplify first before I even show you how to do any of these problems. So here it is, okay? For instance, this first one, this is the type of answer. You could get an answer like this by doing the quadratic formula. 10 plus or minus square root of 500 over 15. Some people would just say, that's my answer, okay? Not good enough. It would be a correct answer at that point. It would not be simplified. So I'm gonna show you how to simplify it. Now, if you remember, we already did, not too long ago, we just did some simplifying of roots. How does that go? You're gonna go like this, 10 plus or minus square root pretty, square root ugly. Remember that? That whole square roots, simplifying roots, right? Square root pretty, square root ugly. What's pretty about 500? What's the pretty perfect square number? Would be 100, right? What's ugly? 5. You take the biggest perfect square number out there that you can, over 15. So all I did from this step to this step is called this square root of 100 times square root of 5. And remember, square root of 100 is 10. So this becomes 10 plus or minus 10 root 5 over 15. Now, sometimes people even get it to that point okay, but don't go on from there. This is not correct at this point. It is correct. Actually, it is correct, but it is not simplified, okay? You have to simplify in order for the answer to be correct. So that you would not get credit for an answer like this, even though it's correct, because it's not simplified. Okay, how do you simplify it? You say, okay, can I factor the top? Look, these two things both have a 10 in common, so I could factor out the 10 and get 10 times 10 divided by 10 is 1, plus or minus 10 root 5 divided by 10 is root 5, over 15 is, well, 15 right now. Now, 10 times this over this. Wait a minute, the 10 and the 15, you couldn't cancel the 10 and the 15 here because these are stuck with pluses or minuses, right? Has to be multiplication before you start canceling. They can't be stuck together with pluses and minuses. But now it's 10 times this over this. So guess what? You can simplify. You could say both of these have a 5, so I can make this a 2, and I can make this a 3, right? Divide each of those by 5, and I'm going to get 2 times 1 plus square root 5 over 3. That would be a fine answer right there. Or if you wanted to distribute the 2, since nothing else is going to cancel, you could call it 2 plus or minus 2 root 5 over 3. That would also be correct. Either one of those would be acceptable. Personally, I would leave it like this myself. But if you did that, that certainly would be okay. That would not be a problem. Okay? That's how you simplify. I'm going to show you a couple more because this is critical. This is what people tend to have trouble with. I've noticed that. So I'm trying to give you guys a heads up on this. Okay, so same idea. Square root 48. Wait a minute, that's 16 times 3. So we could go 8 plus or minus square root 16 times square root 3, right? That's 48. Square the whole thing over 12. Okay. Now, wait, square root 16 is 4, right? This is 4. So it's going to be 8 plus or minus 4 root 3 over 12. Now, everything has a 4. So I can factor out the 4. Okay, 4 times 8 divided by 4 is 2, plus or minus 4 root 3 divided by 4 is root 3 over 12. All I did from this step to this step is factor out that 4. Now I can say, wait a minute, 4 and 12, 4 goes into 12. This could be a 1, this could be a 3, and the answer is going to be 2 plus or minus square root 3 over 3. And then that is the answer. You can't cancel the 3's for 2 reasons, because this is under a root and this is not, but also because these are stuck together with a plus or minus. You can't cancel things stuck together with a plus or minus, right? So there we go. That would be the simplified answer there. Okay, over here, just a couple more along these lines. Okay, 6 plus or minus square root 28. I'm going to go square root pretty, square root ugly. What's pretty about 28? 4. What's ugly? 7. Square root 4 is 2, right? So it's going to be, whoa, I'm getting crazy with these pens, okay? We're going to get, oh, wait a minute, over, I didn't put the denominator, oops, over 4. Okay, now, that's going to give me 6 plus or minus 2 root 7, the whole thing over 4. Notice everything has a 2, so I can factor out the 2. 2 times 6 divided by 2 is 3, plus or minus 2 root 7 divided by 2 is root 7, the whole thing over 4. Now, the 2 and the 4 can cancel, be a 1 and a 2. We get 3 plus or minus square root 7 over 2. And that would be what your answer looks like. Okay? Okay, let's keep going now. What about this guy? Same idea. 16 plus or minus square root pretty, square root ugly. What's pretty about 44? 4. What's ugly? 11 over 2. That's going to be 16 plus or minus 2 root 11 over 2. Everything has a 2. 16 divided by 2 is 8, plus or minus 2 root 11. Pull out the 2 is root 11 over 2. Those guys cancel, and you just get 8 plus or minus square root 11. And there you go. It's that easy. Now, you may look at that and go, that doesn't seem that bad, but I'm telling you, people mess this up all the time. This is the thing that I find people having most trouble with about the quadratic formula, is simplifying it. They don't have so much trouble getting the answers to these points. They have trouble simplifying it from this point on. That's why I showed you 4 examples of simplifying, because I know people tend to have trouble with that more than trouble with the actual quadratic formula. Okay, so now hopefully you have a good grasp on the simplifying part. Now let's actually start using the quadratic formula. It's so important, I wrote it right here, the quadratic formula. If ax squared plus bx plus c equals 0, Then x is opposite of b plus or minus square root of b squared minus 4ac, the whole thing over 2a. This is how that works. First of all, you can solve any second degree equation by this formula. So factoring only works on some things. This works on all of them. However, since we're in Algebra 1, if you get a negative underneath the square root sign, the answer is, we're going to call it no solution. And the answer is actually no real solution, because there's no solution in the real numbers. You have to go beyond the real numbers into the complex numbers to actually get solutions for it, which you guys don't know about. But the good news is, if you take Algebra 2, you're going to learn about it. So it should be motivation for you to get to Algebra 2. But for right now, if you get a negative underneath the square roots, so if this whole quantity here turns out to be negative, I'm just going to have you guys say for right now, no solution. Even though I try not to lie to you ever, so I'm telling you the truth. There is a solution, but it's not in the real numbers. It's not anything that you would be familiar with, so you'll have to just learn more about that when you take Algebra 2. But for right now, if you get a negative under there, let's just call it no solution and move on. You don't have to worry about simplifying or anything like that. Just say no solution and move on, if it's negative. Okay, so anyways, here we go. Solve this by using quadratic formula. Okay, so first thing we do is notice, oh good, the fortune is with me, because look, it's in blah, blah, blah equals 0. It's in the form that I need right here. If ax squared plus bx plus c equals 0. If it didn't equal 0, then I would need to move it around so it did equal 0. But guess what? It already does, so that's cha-ching, that first part's done. So now I just need to figure out what a, b, and c is. A is whatever's in front of the squared term, okay, which in this case is 2, okay. B is whatever's in front of the single power term, the x. B in this case is 6. C is the constant, positive 1. Also, you pay attention to the signs. Like if that was a negative 1, you'd use negative 1 there. Okay. And then you plug it into the quadratic formula. All you do is plug these numbers in for the letters in the quadratic formula. So we got x is opposite of b. The opposite of 6 is negative 6. Plus or minus square root of b squared, so 6 squared, minus 4ac, 4 times 2 times 1, square root of that whole thing, all over the whole thing, including here, everywhere, all over 2a, 2 times 2. I did absolutely no thinking whatsoever. I just plugged numbers in for letters into the formula. I'm like a robot right now, just plugging numbers in for letters. Now I shall simplify. Okay, so here we go. Okay, x equals negative 6 plus or minus. Okay, I'm simplifying what's under here. 6 squared is 36 minus 4 times 2 times 1 would be minus 8. The whole thing over 4. Okay, then I get x is negative 6 plus or minus square root of 36 take away 8 is 36 take away 8 is 28. 28 over 4. Okay? Oh my gosh. That's almost the same as this guy, except for I had regular 6. In fact, I think I meant to put a negative there so that this would already be simplified for us, but oops. Well, let's go ahead and do this. So, root 28 is going to be root 4 times root 7, right? Which is 2 root 7. So x is negative 6 plus or minus 2 root 7, the whole thing over 4. Okay. Everything has a 2, so factor out the 2. X is 2 times negative 3 plus or minus square root 7, the whole thing over 4. Now the 2 and 4 can cancel, and I get, oops, not 1, that's a 2. X is negative 3 plus or minus root 7, the whole thing over 2, and there you go. And notice that actually represents 2 answers, the plus and minus. Look, negative 3 plus square root 7 over 2 is one of the solutions. Negative 3 minus square root 7 over 2 is the other solution. That's just a shortcut way of writing both of those. Okay. So there's that. Okay, how about this guy right here? Well, I'm going to give you a nice tip. Listen to this tip. This can save you much misery. Do you have to get rid, look, is it good for a negative to be in front of our squared term? Usually we say no, and that is usually correct, and that is correct in this case also. First of all, do I have to get rid of the negative here? Could I do this problem by saying my A value is -1? Yes, I could do it that way, but the chance of messing it up go way up if you do that. You're much more likely to mess it up if you have a leading negative coefficient. And then when you plug it into the if an A value is negative, plug it into the quadratic formula can really mess you up. So I highly, highly recommend you never have your A value negative. Do whatever it takes to get your A value to be positive. You're much more likely to do it correctly that way. So I look at this and say, I could call A -1, B is 7, C is -6, but I don't want to do that. I don't want my A value to be negative. Anytime you have a negative A value, you can always change it by just dividing through by -1. Look what happens. I get x squared. It makes all of them change. So we get -7x plus 6 equals 0. Right? So there we go. Now I have a positive A value. Notice I can go A is 1, what's in front of the squared term. B is what's in front of the single powered x term is -7. C is 6, positive 6. Notice they all change signs when I divide it by -1. Now, I just plug this stuff into the quadratic formula. I think you'll be shocked and amazed when you see what happens. X is opposite of B, so regular 7, plus or minus square root of B squared, so it's going to be -7 squared minus 4AC, 4 times 1 times 6, all over 2A, 2 times 1. See, good thing I made it 2 times 1, or you'd be having a -2 down here. I don't really want to deal with a -2 down there if I don't have to. Okay, so here we go. X is 7 plus or minus square root 49 minus 24, the whole thing over 2. Get ready, here it comes, here it comes. X is 7 plus or minus square root of 25. Wait a minute, wait a minute. I know what the square root of 25 is. It's just 5. Oh my gosh. So wait, it's 7 plus or minus 5 over 2? Yeah. So guess what? Guess what I see quite often? I see, okay, there's my answer. Wrong, not wrong answer, but not simplified. Wait a minute, 7 plus or minus 5. You can actually simplify this into 2 rational numbers. Check it out. 7 plus 5, that's going to be 12 over 2, right? 7 minus 5, that's 2 over 2. That equals 12 divided by 2 is 6. 2 over 2 is 1. 6 and 1. They actually give me integer answers, 6 and 1. Oh my gosh. So if you can break it down to that, do it. Don't stop right there. Simplify completely. 6 and 1. You know what that means if you get nice rational or integer solutions like that? It means actually that thing would have factored in the beginning if we wanted to solve it by factoring, but I told you to solve it by quadratic formula. So I wouldn't want you to solve this one by factoring right now because I'm wanting you to see how to do it by quadratic formula. But after I got out of this quadratic formula section, if I were solving this problem, I would usually solve it by factoring. I would not use the quadratic formula on this because it's more work than is necessary. But on this section, I do not want you solving any of them by factoring. I want you doing the quadratic formula on everything. Okay, so here we go. We're just going to plow through a few more. Here's one that's missing an x term. Look, 2x squared minus 10. First of all, 2 things nice about this. First of all, I could use a equals 2, b equals 0, because there's nothing in front of the x term, that'd be 0. C equals -10, and that would be okay. but I'd be dealing with bigger numbers I had, and then I would have some simplifying to do at the end for sure. But another thing I could do to make my numbers smaller is, see how everything has a 2? I could either say A is 2, C is -10, or I could divide both sides of the equation by 2 and get x squared minus 5 equals 0. This equation is going to have the same set of answers that does. It's just going to take less simplifying, and I'm going to be dealing with smaller numbers. So why not do that? Anytime your polynomial has a common factor that you can divide out, do it. It makes the numbers smaller. It makes the simplifying less. Sometimes you don't even have to simplify at the end. I can guarantee you, if they have a common factor like this that you don't divide out, you will have to simplify. Okay, so here we go. Wait a minute, x squared plus 5 equals 0, so I can go A equals 1, B equals 0, C equals -5, right? There's my A, B, and C. So an A value of 1 and a C value of -5 gives you the same answer in the long run as an A value of 2 and a C value of -10. So let's go ahead and do it. It's going to be, so we're going to get x is opposite of B, so opposite of 0 is 0, plus or minus square root of B squared, so 0 squared, minus 4AC, 4 times 1 times -5, over 2A, 2 times 1. Now, I just noticed something that people tend to have trouble with that I try to warn you guys about right here. Watch this. This is a common mistake people make as well. Equals 0 plus or minus the square root of 0 minus 4 times 1 times -5. Notice, minus. This is going to be a minus a negative number. It's going to net out to be a plus. 4 times 1 times 5 is 20. It ends up being a plus 20. The minus and the minus combine together to be a plus. Sometimes people have trouble with that, so I'm just pointing that out to you. Okay, then we get x is 0 plus or minus square root 20 over 2, and then square root 20. So square root pretty, square root ugly. What's pretty about 20? 4. What's ugly? 5. Divide by 2. And remember, square root 4 is known as 2, right? So this is going to be 2. So this is all going to be x is 0 plus or minus 2 root 5, the whole thing over 2. Now, 0 plus or minus this over 2, the 0 doesn't do anything. So really this nets out to just be plus or minus 2 root 5 over 2. And then the 2's can cancel, and you get plus or minus square root 5. So what does that mean? Positive square root 5 is one solution. Negative square root 5 is the other solution. So that's how that works. 2 more to go. 2 more to go. And then you will have a worksheet that I created for the quadratic formula. So 2 more. Here goes. Actually, I'll get them over to here on the screen as well. There's the first one that I'm going to do. Okay, so here we go. It's going to be negative 3x squared plus 5x equals -2. Okay, the first thing you notice here is, well, darn, there's not a 0 over on one. Look, ax squared plus bx plus c equals 0. I don't have equals 0. So I have to get equals 0. How do I do that? I either wipe out this side and make it 0, or I wipe out this side and make it 0. How do I decide which side to wipe out? Here's how I do it. Some people might go, well, look, if I would only have to move one thing over here to make this side 0, but I'd have to move 2 things over here to make it 0, so I'll just move this over. I disagree. That's not what I would do. I would move these 2 guys over. Why? Because the thing in front of my squared term is negative. Remember I told you We don't like negatives in front of our squared term. I would do whatever it took to get a positive in front of my squared term. So what would I do here at the first step? I would move these guys over here, making this side 0. That is exactly what I'm going to do. That's going to give us, let's see, that's going to give me 0 equals 3x squared, yay, positive, minus 5x minus 2. It doesn't matter which side of the equation the 0 is on, okay? This is fine. So now I can say A is 3, B is -5, C is -2. And put it into the quadratic formula. That's going to be easy enough. Okay, so I'm going to go x is opposite of b. So opposite of -5 is regular 5, right? Plus or minus square root of b squared. So it's going to be -5 squared minus 4ac. 4 times 3 times -2. 4ac all over 2a. 2 times 3. All I did, notice, was plug in numbers for letters into the quadratic formula. Well, gee, what if I don't know the quadratic formula? Well, you better learn it. That was the whole point. You gotta memorize the quadratic formula. So here we go. So x is 5 plus or minus square root of 25 minus. So look, the minus and the minus net out to be a plus. 4 times 3 is 12 times 2 is 24 over 2 times 3 is 6. And then, oh my gosh, I see it. Do you see it? Here it comes. Here it comes. Oh my gosh, 49. I know 49. 49 is a perfect square. It's just 7. So wait a minute. It's going to be 5 plus or minus 7 over 6 equals what? What does that equal? Well, let's see. 5 plus 7 is 12, so 12 over 6. And 5 minus 7 is -2 over 6. Well, that simplifies, I'll just do it over here. That simplifies to 12 over 6 is 2, right? And -2/6 is actually -1/3. So there you go. 2 rational solutions. So that means that that thing actually would have factored if we would have tried to factor it. But again, on your homework, I do not want you to solve them by factoring this time. I want you to solve them by quadratic formula. I want you to practice with the quadratic formula. Okay, one more problem. Okay, here we go. Okay, 2 minus 5y squared equals 9y. Sometimes we run into equations that don't have x as their variable. In this case, y is the variable. So here, if it's ax squared plus bx plus c equals 0, then x equals, well, wait a minute. This doesn't have x as the variable, it has y. So then it's just going to be y equals that. It's no big deal. If they use a different variable than x, then just call this thing whatever variable they use. Okay. So now, but again, look, there's a negative in front of my squared term. Bad, bad. I don't want that. So I'm going to fix it. I'm going to move this side over here, minusing 2, cancel that. Add 5y squared, add 5y squared, cancels that. There we go. 0 equals, I like to put them in the right order. 5 squared plus 9y minus 2. Now, plug that into the quadratic formula. A is 5, what's in front of the squared term. B is in front of the single power term, 9. C is -2. Plug that into the quadratic formula. So here we go. Okay, I'm going to get y in this case equals opposite of b. Opposite of 9 is -9. Plus or minus square root of b squared, so 9 squared minus 4ac, 4 times 5 times -2. The whole thing over 2 times 5. 2 raised 2 times 5. Okay, now y equals -9 plus or minus square root of 81 minus nets out to be a plus. 4 times 5 is 20 times 2 is 40. And it's over 10. Okay, let's see what that turns out to be. That's going to give me -9 plus or minus, let's see, 1 plus 0 is 1, 4 plus 8 is 12, 121. Wait a minute, that rings a bell. 121 is also known as, a square root of 121 is 11. So this is going to be y is -9 plus or minus 11, the whole thing over 10. So -9 plus 11 is 2 over 10. -9 minus 11 is -20 over 10. So they're going to be 1/5 and -2 are the two solutions. Like that. That's how it works, people. Yeah, so no big deal. So your homework will be a worksheet that I made up for you called the Quadratic Formula 1 worksheet. Now pay attention to this. Look at the video right here. I want to show something very important. Your homework is the Quadratic Formula 1 worksheet, correct? Wait, is that your homework? No, that's part of your homework. Read underneath it. Memorize the quadratic formula. That is a very, very important part of your homework, right? Memorize the quadratic formula. That's a very important part. Wait, is that all? Is that all? No, it's not all. Watch this. Don't just memorize the quadratic formula. Listen to me, people. Don't just memorize the quadratic formula. Memorize the quadratic formula correctly, right? If you memorize it incorrectly, you are in for much misery. Memorize it and memorize it correctly. See ya next time.